Namaste to everyone. I welcome you all in my channel. Today I will discuss on the remaining problem of previous lecture, and then I will focus on tensor of rank 2, which will include contravariant tensor of rank 2, covariant tensor of rank 2, mixed tensor of rank 2, higher rank tensors, etc. As we have already discussed 7 problems in my previous lectures, today it is 8th problem. In this problem, if a vector has components x double dot and y double dot in rectangular Cartesian coordinates, then find corresponding components in polar system of coordinates. Here, Cartesian system and polar system, two systems of coordinates. We generally consider Cartesian system as x system of coordinates and polar system as x bar system of coordinates. In previous lectures, we have seen the different relations between Cartesian system of coordinates and polar system of coordinates, in which we have seen that r square equal to x square plus y square, theta equal to tan inverse y by x equal to r cos theta, y equal to r sin theta, del r by del x equal to x by r, del r by del y equal to y by r, del theta by del x equal to minus y by r square, del theta by del y equal to x by r square. These are the relation between Cartesian and polar system of coordinates. We have also considered xy equal to x1, x2, r theta equal to x bar 1, x bar 2. We have already seen that velocity vector is a contravariant vector. Similarly, acceleration vector is also a contravariant vector. Here, x double dot is the acceleration along x axis and y double dot acceleration along y axis. We write x double dot as a1, y double dot as a2, since xy equal to x1, x2, r theta equal to x bar 1, x bar 2. Now, according to the tensor law of transformation for contravariant vectors, a bar I equal to del x bar I by del x alpha a alpha. Here alpha be the dummy suffix. So It represents the summation. We expand this del x bar I by del x1 a1 del x bar I by del x2 a2. Putting I equal to 1, a bar 1 equal to del x bar 1 by del x1 a1 plus del x bar 1 by del x2 a2 equal to del x bar 1, x bar 1 is r, del r, x1 is x, del x, a1 is x double dot. Similarly, x2 is y, a2, and del r by del x is x by r, x double dot, y by r, y double dot. This is x double dot plus y, y double dot by r. This is equation number 1. Now we have to find the value of this number 1. So we differentiate this equation both sides with respect to t. dr by dt is r dot, d2 r by dt square is r double dot. So 2r r dot equal to 2x x dot plus 2y y dot implies that r dot equal to x dot plus y dot. Again differentiating with respect to t, we get r dot square plus r double dot equal to x dot square plus x double dot plus y dot square plus y double dot implies that r dot square plus r double dot minus x dot square plus y dot square equal to x double dot plus y double dot. That this is 2. Again, differentiating both sides of this equation with respect to t, we get x dot equal to r dot cos theta minus r sin theta dot. Again differentiating this equation both sides with respect to t, we get y dot equal to r dot sin theta plus r cos theta dot. Squaring both equations and then adding, we get x dot square plus y dot square equal to r dot square cos square theta plus r square sine square theta, theta dot square, minus 2 r dot theta dot into cos theta sin theta plus r dot square sin square theta plus r square cos square theta, theta dot square plus 2 r dot theta dot cos theta sin theta. Here this is minus negative term and this is positive term, cancels with each other. And here if we take r dot square common, then we will get r dot square into cos square theta plus sin square theta. That is 1, that equal to r dot square. Here also if we take common r square theta dot square from these two terms, we get sin square theta plus cos square theta, that is 1. So this will give the result r square theta dot square. If we put this result in equation 2, we get r dot square plus r double dot minus r dot square minus r square theta dot square equal to x double dot plus y double dot, implies that r dot square and r dot square cancel with each other. So this minus r square theta dot square equal to x double dot plus y double dot, implies that r double dot common r theta dot square equal to x double dot plus y double dot, implies that r double dot minus r theta dot square equal to x double dot plus y double dot by r. Putting this result in equation 1, we get a bar 1 equal to r double dot minus r theta dot square. So this is the first component of contravariant vector in polar system of coordinates. As a bar 2 equal to del x bar 2 by del x1 a1 plus del x bar 2 by del x2 a2. X bar 2 is theta. So del theta, del x1 is x, a1 is x double dot, del theta, x2 is y, and a2 is y double dot. And this is del theta y del x is minus y by r square, x double dot plus del theta by del y is x by r square, y double dot equal to x y double dot minus y x double dot by r square. Now we will find the value of x y double dot minus y x double dot. So we take help theta equal to tan inverse y by x, differentiating both sides with respect to t, we get theta dot equal to 1 by 1 plus y square by x square into x y dot minus y x dot by x square. This is x y dot minus y x dot by x square plus y square, that means r square, implies that r square theta dot equal to x y dot minus y x dot. Again differentiating both sides with respect to t, we get 2r r dot theta dot plus r square theta double dot equal to x dot y dot plus x y double dot minus y dot x dot minus y x double dot. This term and this term cancel with each other, so we get x y double dot minus y x double dot. Dividing both sides with r square, we get 2 by r dot theta dot plus theta double dot equal to this, putting this value in a bar 2 by r dot theta dot plus theta double dot. So we get a bar 1 equal to r double dot minus r theta dot square, and a bar 2 equal to theta double dot plus 2 by r dot theta dot. These are the components of contravariant vectors in x bar system of coordinates, that is in polar system of coordinates. So these are the corresponding quantities of x double dot and y double dot. Now we will discuss on contravariant tensor of rank 2. As we have already learned, contravariant vector of rank 1, in which we have seen that a bar I equal to del x bar I by del x alpha a alpha. In the case of contravariant vector, that is the tensor of rank 1, the vector is a tensor of rank 1. Here case is contravariant. In contravariant case, we write I as superscript, and in right side also x bar I is in upper position. This is the way of writing contravariant tensor or contravariant vectors. Similarly, contravariant tensor of rank 2, we will follow this rule. Let we have a ij equal to 1 to n, in which we get n square number of quantities, a11, A12, A13, and in this way we get n by n matrix. So in that matrix, number of quantities will be n square. According this is the contravariant tensor in X system of coordinates. Let corresponding quantities in X bar system of coordinates be A bar ij. Similar to this equation, we will write the transformation as del x bar I by del x alpha. Here for j, del x bar j by del x beta, and here alpha beta. Here ij are as a superscript, so x bar I and x bar j will be on top position. This is the tensor law of transformation of contravariant tensor of rank 2. Our next problem is to covariant tensor of rank 2. As we have seen, covariant vector as A bar I equal to del x alpha by del x bar I A alpha. Here the position of I as subscript in left side and x bar I is in the lower position. Similar to the contravariant tensor of rank 2, we have Aij, I and j as subscript for covariant tensor, and where I, j equal to 1, 2, n square number of quantities in X system of coordinates. Its corresponding quantity in X bar system of coordinates is A bar ij. Similar this transformation, we may write del x alpha by del x bar I, del x beta by del x bar j, A alpha beta in the lower position. This is the tensor law of transformation of covariant tensor of rank 2. Now we discuss the mixed tensor of rank 2. Let Aij equal to 1 to n be n square quantities in X system of coordinates. Here it is said to be mixed as I is as superscript and j as subscript. Here mix in the sense that I denotes contravariant and j denotes covariant. Its corresponding quantity in X bar system of coordinates be A bar ij, and we may write this as tensor law of transformation del x bar I by del x alpha, I at upper position, here also this, and then del x beta by del x bar j, j is at lower position, here also, and A alpha beta. This is the tensor law of transformation of a mixed tensor. Now we discuss about tensor of higher rank. Let Aij dot dot k be a tensor in X system of coordinates. This tensor is a contravariant tensor. Its corresponding value in X bar system is A bar I j k. According to the tensor law of transformation, delta X bar I by del X alpha, del X bar j by del X beta, dot dot dot, del X bar k by del X gamma A alpha beta dot 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 gamma. Similar to this, we may consider the case for a tensor in covariant. Let A I j dot 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 k be a tensor, that is covariant tensor in X system of coordinates. Its corresponding value in X bar system of coordinates be A bar I j dot dot k. According to the tensor law of transformation, for covariant tensor, we write here x del X alpha by del X bar I, del X beta by del X bar j dot dot dot, del X gamma by del X bar k A alpha beta dot 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 gamma. Now we shall discuss on a tensor of higher rank for mixed tensors. A I j k be a tensor, that is mixed tensor, in X system of coordinates. Its corresponding value in X bar system of coordinates be A bar I j k. According to the tensor law of transformation, this equal to del X bar I by del X alpha, del X bar j by del X gamma by del X bar k A alpha beta gamma. Thank you for watching my YouTube video. I will discuss the addition and difference of two tensor, inner product and outer product of tensors in my next lecture. If you are satisfied with my YouTube video, then please click on like button and do subscribe my YouTube channel. Thank you.